So hey everyone, I am Satwik. Today we are going to solve another CodeChef contest. We will start from division 4. The first question in division 4 is protein diet. Okay, so the question says you consumed X grams of protein daily. A balanced diet requires Y grams of protein per day. To determine whether your daily protein intake fulfills the recommended requirement. The daily protein intake is considered fulfilled if and only if X is greater than equals to Y. Okay, so we are given two integers X and Y, where X represent the amount of protein I consumed amount of protein, and Y represent required, and my needs are only fulfilled if X is greater than equals to Y. So we just need to check that only. So it's a pretty simple question. uh, okay, so here I'm taking to input X and Y. If X is greater than equals to Y, then you will just print yes, you will going to print no. Let's just submit it. So yeah, it's working. Now quickly moving to the next question, that is winter is coming. Chef feels comfortable depending on the temperature and whether or not he is wearing a jacket. Okay, so some conditions are there. Chef feels comfortable without a jacket if and only if the temperature is greater than equals to A. Okay, the next one is chef feels comfortable with a jacket if and only if the temperature is less than equals to B. Okay, it is guaranteed that A is less than equals to B. Okay, chef is not wearing a jacket initially. Yeah. Now you are given a temperature Ti for the next n days. A chef can choose to wear or remove his jacket any number of times, but each time he puts on the jacket, it's count as an action. Find the minimum number of times chef need to wear a jacket. Okay, so let's first discuss the conditions that has been given. So there are two numbers given A and B, and chef can either wear a jacket or he does not have a jacket. No jacket. That means he's not wearing a jacket currently. Okay. So the conditions for being comfort are first one. The first one says that chef feels comfortable without a jacket even only if temperature is greater than equals to A. Okay. So if temperature is greater than equals to A, chef is comfortable without a jacket. So no jacket is all right. If temperature is less than A, then I think he will feel cold, so he is not that comfortable. Okay. Now, chef feels comfortable with a jacket if and only if temperature is less than equals to B. So after putting his jacket, he is comfortable up till temperature is less than equals to B. If temperature is greater than B, he is not comfortable with a jacket. Okay. So that means sorry. If temperature is greater than equals to A, that means no jacket is cool. If temperature less than B, that means sorry. If temperature is greater than B, that means he cannot wear a jacket. In this case also he cannot wear a jacket. Okay. So if I divide the temperatures, okay, let's say it is A and it is B. Below this point, chef need to wear a jacket, otherwise he is uncomfortable. Below this point, jacket is required. Okay. And if temperature is greater than B, he won't be comfortable and he need to remove his jacket. So during this point, I cannot wear a jacket, no jacket. And this range, that is from this range actually, close bracket of A and B, this range, chef is fine with jacket and no jacket. So both are actually fine. He can wear jacket and he also not choose to wear jacket. Okay. So now uh, we are given an array of length n, where where each element represent a temperature. Okay. Now every time for its temperature, if the chef need to wear a jacket, then it's count as an action. So our objective is to find the minimum number of action that is required to make the chef comfortable all the time. Okay, for an example, 15, 25, 35, 28, 10. Okay, the array is 15, 25, 35, 28, 10. Sorry, 35, 28, 10. Okay, 28, 10. And the value of A and B is 20, 30. Okay, so let's me first draw the number line. This is the point A. It's already given A is always less than equals to B, 20, 30. Now, this point means I need to wear a jacket. Wear jacket. Sorry, jacket. And more than B means remove jacket. Remove. Okay, let's start. Initially, also it is given that initially there is no jacket. Okay, so initially my jacket is let 0 represent no jacket. Okay, so now the first is 15. Okay, so 15 is less than 20, less than A. That means I need to wear a jacket. So number of action will be +1 because wearing jacket counts 1. plus 1. So my current count is 1, and my jacket is 1 because now I'm wearing a jacket. Okay, so after that there is 25. As 25 resides between A and B, 25 actually resides between A and B. That means I can wear a jacket, I may not wear a jacket, there is no issue. So I do not need to remove my jacket. Okay, move forward 35. Okay, 35 is actually uh, process B. That means here I need to remove my jacket. So I will just remove my jacket and my jacket will be 0. That is, currently I'm not wearing a jacket, but my action won't increase because removing a jacket does not count as an action. Next I went to 28. Now 28 means between A and B. That means I'm fine with or without a jacket, so it won't count. And again at 10. 10 means that I am in this range less than A, and I am currently my jacket is 0. That means I am not wearing a jacket. That means again I need to wear the jacket, though the action will increase by 1. And that ends. So minimum number of times or minimum number of action required to make the chef comfortable is 2. So it's basically we are going to write some if and else conditions and maintain a binary variable jacket that will represent whether I'm currently wearing a jacket or not. So let's just quickly write the code. Okay. So initially some test cases are given. Okay. Now coming to the main function. First, it's given the length of the array. Now the temperature vector. Now let's take input. Yeah. Okay. Let's just check the input format. I think yeah, A and B is also given in that line. Okay. So okay. Yeah. Now writing the conditions. That means I will just try to implement this number line only. Okay. Also, I need a variable jacket. This is a binary variable. 0 represents no jacket and 1 represents jacket. Okay. Now I will start iterating the array. Okay. So if my temperature is actually less than A, so what are the conditions that I am wearing a jacket? Okay. So if my temperature is less than A and I am not wearing a jacket, then only I will wear a jacket. So let's just write it. If temperature is actually less than A and then my jacket is 0, then I will wear a jacket. Okay. So let's just also initialize my answer. That means I am going to wear a jacket. My answer will increase and my jacket will currently be 1. Okay. And there is a case where I'm going to remove my jacket. That case is if, okay, let it be, if temp is actually greater than B, then I'm going to remove my jacket. That is, jacket will be 0. All the other cases is already handled because I'm going to wear jacket only if it's less than A and jacket is 0. That's handled. My answer will increase, my jacket will be 1. And I'm going to remove my jacket if my temperature is greater than B. So if my temperature is greater than B, then jacket will be 0. So it's this part of the code is actually implementing this lambda line. Now I'm going to return my answer, and I think it should work. Let's just check. Return. Okay, sorry. Again, I need to print my answer. Not return. Yeah. Okay, so 2-1. I think it should work. Yeah, it's working. Okay, now moving towards the third question. Odd string. Sorry, it's already done here. I will remove it. Okay, so the question says you are given a string s of length n consisting only of lower English letters. A string is called odd string if and only if for every pair of indices I less than j such that s of I is equals to s of j, the distance between them is odd. That is j minus I should be odd. Okay, so that means In the third question, uh, I've given a string of length n. It contains lowercase English letters, okay, of length n. Now it's been said that a string is called odd. I will call a string odd if the following condition follows. For every index I less than j, if s of I is double equals to s of j, that is, if s of I is equals to s of j, then j minus I should be odd. Okay, j minus I should be odd. That means for a string to be odd for all I less than j, if s of I is equals to s of j, then j minus I should be odd. For an example, let's take a simple example. Uh, A B C C B D. Okay, A B C C D D. Okay. So coming to for all pairs of ij, let's say uh, A and A are equal. That means here I 0, 1, 2, 3, 4, 5, 6. Okay. So the pair where s of I is equals to s of j, let's check 0 and 1. A and A are equal. And 0, 1 minus 0, that is j minus I is actually 1, which is odd. So it's fine. Now coming to B, no, I think, yeah. So B is only 1. So no operation will take place. Now coming to C, 3 and 4. 4 minus 3 is actually 1. That means it also follows. Now coming to D, 6 minus 5 is equals to 1. That is also odd. So actually this entire string is odd. Coming to another example, let's say it would be like this: A C B D. Okay, let's go. Uh, no, A C B A. Yeah. Now the index. Let's write the index first. 0, 1, 2, 3. Yeah. So first A appears at 0, then A appears at 3. Now 3 minus 0 is actually odd. So that means A follows. Now C is occurs only one time and B also occurs only one time. That means this string also is actually odd. Now the question says that the question does not directly say that to find whether the string is odd or not. The question states, uh, okay, you are allowed to arrange the character of the string in any order. Determine whether it is possible to rearrange S such that it becomes an odd string. Okay, so that means given a string S, I can reorder the character of the string, and then I need to tell you whether I can reorder it in a certain way so that the string becomes odd. For example, let's say the string is currently like this: A B A B B A. Okay, one second. Okay, so let's just resume from where we left. Okay, so the main idea is that whether we can rearrange the string to make it an odd string or not, right? So for an example, let's take a string that is AB. Initially, let's just write the index first. That is 0, 1, 2, 3. Now, for A, the indexes are 0 and 2. 2 minus 0 is 2. That is even. So it is not following the condition. And from for B also, the indexes are 3 and 1. That is 2. It is also not odd. So that means the string is actually not odd. Now, can I rearrange them and make the string odd? Yes. If I rearrange AB as AABB, now the indexes are 0, 1, 2, 3. Now for A, the indexes are 1 minus 0, that is 1, which is odd. And for B also, that is 3 minus 2, it is 1, and it is also odd. As both, for all the indexes, it is the difference is odd. The difference of I minus j says that A of I is equals to A of j is odd. That means the string is odd. So I need to do that. I need to check whether I can rearrange them in order to make them odd string. Okay. So now how can I do that? Now I will tell you two main observations that will solve this problem. First thing, I need I and j such that j minus I is odd. So first thing is that which number causes a odd difference? Can two even number causes a odd difference? It cannot, because two even numbers are actually represented as 2n, or let another be 2n plus 2. Now their difference will always be even. So two even number can never be, the difference of two even number can never be even. Similarly, can two odd number be, difference of two odd number be can even? No, it's also not. Even number can be represented as 2n plus 1 and 2n plus 3. Now the difference is 2, which is not even odd. That means the difference of two odd number can never be odd. So if both the indexes are even and both the indexes are odd, the difference is even. So in order to make them odd, one index need to be even, another need to be odd. So between I and j, uh, any one of them need to be even and other need to be odd. So this is the first observation. Okay. The second observation is that, okay, uh, let's say there are three A. Okay, there can be in between there can be various numbers. X represent any number. For this case, there are three A's. Okay, So in order to rearrange the string, and make it as odd, I need to keep all the indexes of a one in odd and other in even, like that. So let's the first a let it let me keep the first a at even position. It's my choice. Let's keep the second a at odd position, because if I keep this in even position, then both I and j will be in even position and the difference will be even. So let just first keep the first day at even position, the second day at odd position. Now the question arises, where should I put the third day? Because I also need to rearrange that, right? If I put the third day at odd position, then these two odd position value will, the difference of these two odd position indexes will be even. And if I put a in even position, that these two even position indexed a will cause the difference to again be even. So one interesting and important observation is that the count of distinct element can never cross 2. If they cross 2, then I cannot rearrange them, because for 2 I can put one at even position and one at odd position, it's fine. The difference will be odd. But as soon as the third number comes, where should I put it? If I put it even, then these two even will cause a odd even difference. And if I put it as odd, then the two odd will cause a even difference. So the last observation is that the count cannot be greater than 2. The count of distinct integers can never be greater than 2. So this is the main crux of the problem. Let's just solve it. Okay, I have written taken input the test cases here. So I just need to input the n and the string. You can use a map, but for convenience, I'm using an array because the length is only, I think, lowercase English letters are used. So I can take a vector of 26 length. And initial count, let it be 0. Now let's traverse the array or the string, sorry. Uh, in S. Let me first calculate the index. Index should be it minus a. Okay, so if you're confused that what is it minus a, you can actually convert it to ASCII, then subtract it with 97. I think it is a ASCII value of a. But if you do it directly like it minus small a, then it will convert you to that. It will directly give you the index. Okay. Now what I need to check, I need to just increase the count. Uh, while the count will increase by 1, nums of index will increase by 1. Okay. That means the count of A is increased by 1 because index A represents 0. So count of 0 increased by 1. Now I just need to check if nums of index is greater than equals to 3 or not. If it's greater than equals to 3, then it's never possible to rearrange them. So I can just straight away say no, it's not possible to rearrange. Okay. So endl, and I can return. And else in all the cases it's possible. So that means I can just write yes. Okay. So let's just check it. Okay, so there is an error issue, I think. Let's check. Yeah. If nums of index is greater than equals to 3, see out no. Okay, I'm not taking the inputs. Sorry. Yeah. So yeah. Yes, yes, no, yes, no, yes, 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 no. Yeah, it's working. So the main thing you need to observe in this question is that, first of all, the difference thing, that is I and j should always be at even and odd position. It can be or vice versa. And the next thing is that if the count of any distinct number is greater than 3, I can never arrange them. Yeah, this is the main crux of this problem. So let's just submit it. Let's see. Yeah, it's working. Now moving to the last question. It's also a good question, odd operations. Okay. Okay. So this question states, you are given an integer n. You can perform the following two types of operation on n. Okay. So first is digit subtraction. Choose any digit present in the current decimal representation of n and subtract it from n. Okay. The second one is digit reordering. Rearrange or permute the digits of n to form a new integer. A condition is given: leading zeros are not allowed. That means 1067 can be arranged to 7160, but not 10607. I think there is a problem. Also, 90 cannot be arranged to 9. So, okay, so this represents the actual scenario. That means if there is 90, we cannot reorder it to 09. Okay, that means leading zeros are not allowed. That means 100 cannot be reordered to 001. Fine. So, if I reformat the question states that in the sorry, 1 second. Okay, so the question states the fourth question gives us an integer n. The objective is to convert this n into an odd number and minimum number of operation to convert it. This n into an odd number. Now, the operations are first one, digit subtraction. Digit subtraction states, let's digit subtract. In this operation, if I apply this, I can take any digit inside of the number within n. I can take any digit and subtract it with n and check whether the result is odd or not. The first operation is digit subtraction, and the second one is, I think, reordering. Sorry, yeah, the second one is digit reordering. That means the number n can be reordered in any way possible, but there is a condition given that leading zeros are not allowed. That means if the number is, let's say, assume 100, then I cannot reorder the number to 001. Or if the number is, let's say, 202, sorry, no, it will be 203. I cannot order it to 023. I need to order it as 302 or something. That means this zero cannot be in the zero cannot be in the first. Okay, so using these two operations, I need to convert my number n into odd. Minimum number of operation required is our is what the question is actually asking. Okay, so let's how can I approach this code? The first thing is just straight away check whether the number is already odd or not. Okay, the first thing I'm going to do is that check if it's odd or not. Okay, or not. Now, if you try two or three examples, you will always find that any number can be actually converted to odd by applying these two operations. This is subtraction and rearrangement. Every number can be converted to an odd except uh, the number less than 9 and even. Those numbers we can never convert them into odd. For example, uh, 024. I think the number is actually greater than 1, so 0 is not. Yeah, so 0 is not applied. So 2468. Except these four numbers, every number can actually be converted into an odd. First of all, this is the first observation. Then I'm going to optimize the number of operations required. So if your answer is any of 2468, then just straight away write no, okay, or return -1. That means it cannot be converted into odd. Okay. Now the third observation. In the third observation, uh, if if your number actually contain odd, you're getting, if the number n contain any odd digit, not necessarily in the first place. If the number contains any odd digit, that means the number of operation required is always 1. For example, 1 to 2. Okay, it contains one odd. In one operation, I will just rearrange it 2 to 1. That means only in one operation it will be odd. It's even, but it contains an odd digit, that is 1. I will just rearrange it. And another example can be like this, 900. Okay, now this number is actually even, but it contains an odd digit. But can I rearrange it? Can I just convert it to 0019? No, I cannot, because it's already stated that leading zeros are not accepted. But I can use the other operation, that is subtracting. I can just subtract 9 from it. From 900, I can just subtract 9. Now, as this is even and 9 is odd, that means the answer will always be odd. So, given any case, if the number contains any odd digit, the answer will always be 1. Okay. Now, coming to the fourth and the last case. Okay. That means all the digits are even. All the digits are even. For example, let's say 246. And let's take another example, that is 248. Okay. Let's take two examples, 246 and 248. All the digits are even. 246 all are even. Here also 248 all are even. Now, how can I convert them, or minimum number of operations? Now, you can directly see that by rearranging, I can never solve it, right? Because all the number are even. If I even rearrange, then the unit plus digit will always be even. So rearrange is not the solution. So what can I do? The only solution is subtract. Now, one thing is that as 246 all are even, that means If I move 246 to its just to its lesser than 10's value, that means 2 3 something, that means as all are even, then if I reduce it by 1, then reduce it by 10, try to reduce it by 10, that means it will always be odd. The tens digit will always be odd, right? Okay, so every time what I'm going to do is that from 246 I will try to find the maximum digit. It will be either 246, in this case it's 6, and I will reduce it by that number, because that's the only possible choice that I can use to reduce 246 into 2 3 something, that means reduce the 10th place value. So if I subtract it by 6, the answer will be 240. Okay. And here also 248, I will pick the largest digit, 248. That means in this case it's 8. And I will subtract it by 248. That is the first operation, obviously. The first operation. Here, after subtracting it by 248, what's the answer? No, let's take another example rather than 248. Let's take something like uh, 248. Let's take 482. Yeah, it's better. Now in 482, what is the highest digit? 8. Now I am going to subtract 8 from 482. What's the answer? It's after subtracting, the answer is, I think, 484. Yeah. No, sorry, 474. 482 minus 8 is 474. Okay, fine. You can directly see that my second place value is actually, but my 10th place value become 7, because all are even. If I reduce the 10th place, if I am able to reduce the 10th place value by 1, then it will become odd. Now in the immediate next operation, in this case, in the immediate next operation, I can just rearrange and my answer will be 447. So within two operation, I can convert this. I can convert this within two operations. Now coming to this example. Here, after subtracting 246, where 6 is the highest number, the value became 240. We can see that my 10th place value actually does not changes. In this case, it's just, in this case, 482, the 10th place value directly changed after subtracting once with the highest digit. But in this case, 246, the 10th place value does not change. So I need another operation to reduce the 10th place value. I can subtract it by any number. It does not matter, because as it became 240, if I even subtract it by 2 or 4, the answer will, the 10th place value will decrease to 2 3 something. So if I subtract it by 2, the answer will, the number will become 238. Now this comes to the stage where I have a odd number in my number. Sorry, I have an odd digit in my number. Now I can rearrange. So in the third operation, I will just rearrange. So this is the final case. So again, explaining all the cases. First is where zero operations are required. That is the case where the number is okay. Again, explaining the cases. The cases are first already odd. Okay, already odd. That means zero operation required. Now coming to the case where the number is not odd, but there exists a odd digit inside of the number. Odd digit case. That means in the odd digit case, the answer is always 1, because there is an odd digit. That means I can either rearrange it, and if the numbers are of the format of 100 or 900, then I can subtract it by 9 or 1. That will directly give me an odd number. Now coming to the final case where all the digits are even. What I'm going to do first? What I'm going to do? First I will just subtract it with the highest digit, because as all the digits are even, I am going to try to reduce the 10th place value, decrease the 10th place value by 1. So I will just subtract the number with the highest digit and just check. After subtracting, I will just check if the 10th place value decrease or not, or if, for example, I'm giving again the same example, 246. By subtracting with the highest place value, if there is a question why the highest place value, because if I try to subtract it by any lower digit, then what will happen? I will just increase my number of operations, because the tens digit never decreases, and subtracting an even with the even will only cause an even. So there is no help there. Okay, so after subtracting with the highest digit value, the answer becomes 240. But my 10th place value does not change. So I can directly check if whether my 10th place value changes or not, directly by checking whether the 0th place value or the 1's place value is 0. If 1 place value is 0, that means the 10th place value does not change. And coming to another example, that is 482. No, 482 can be an option. After in this number, if I subtract with the highest digit, the answer becomes 474, I guess. 4. And if I check that my 10th place value actually not 0, that means the second place value actually have changed. sorry, I've said the vice versa thing. If my ones place value is not 0, that means my tens place value have actually changed and decreased by 1, right? So after subtracting by the in the even, if all the digits are even, after subtracting by the highest digit, I will check if the ones place value is 0 or not. If it's 0, then I need another operation to reduce the tens place value and then rearrange. So total operation required are 3. And if the ones place value is actually not 0, that means the tens place value have already changed by after subtracting, so it's become odd, so I only need one more operation to rearrange, so the number of operation is 2, right? So let's take an example now. For example, 343 and 2, okay, 246 is already given, no? Let's first check 3. Okay, 343 is already odd. Let's create our own example. 800 uh, 32, right? First, what I am going to check, if there is a odd digit. Yeah, if there is a odd digit, that is 3. So I can directly rearrange it. My answer will always be 1, as the number is not odd. First of all, if first thing that you are going to check is that the number is directly odd or not. Okay, now taking another example, that is, let's say 882. Yeah, 880, 882. Okay, so all the digits are even. So what I'm going to do, so rearranging won't work. So what I'm going to do, I'm going to subtract it with the highest digit, that is 8. So after subtracting, what is the answer? 700 and sorry, 874, right? 874. What I'm going to check, the ones digit place. The ones digit is not 0. That means the tens digit have already changed to an odd value. So that means I only require one more operation. First operation of subtraction. Then I require one more operation to rearrange. So answer is 2. In the case, for example, let's say 228. For this example, 228. All the values are even. So what is the highest digit? 8. Now I'm going to subtract it. First operation of subtraction. After subtraction, what is the value? 220. Now what I'm going to do? I'm going to check whether the zero digit is 0 or not. Sorry, ones digit is 0 or not. The ones digit is 0. That means the tens digit actually does not change. Here it's 2 and it does not change. So it remains 2. So I need another operation. I need another operation to decrease it. After decrease it with again by 2 or something, you can subtract it by 2, as there is no other digit here. So after subtraction, what the number becomes? 218. Now again, I'm going to check whether the zeroth place is uh, sorry, the ones digit is 0 or not. It's not 0. That means my tens digits have now changed to an odd number. So now I only require to rearrange it. So total I require 3 operations. I can rearrange it to form 281. So in this case, I require 3 operations. So I've explained all the cases. Now let's code this. Okay. So just take the number as input. And okay, so first check whether the number is directly odd or not. Sorry, if the number is not it directly odd, then you can just return 0. Okay, so it's int, so there is no issue. Directly odd, then return 0. Another thing that I have mentioned earlier, that we can never convert a number to odd if the number is 246. So I can directly check if n is 2 or n is 4 or n is 6. 246 8 also is 8 is also there. N is 8. Then just what I'm going to do, I'm going to return -1 because it's not possible. Now what I'm going to check, I'm going to check this condition if there is even any odd digit there or not. So I'm going to traverse the number. Let's just replicate it so it will be easier to traverse. Okay, so I'm going to traverse the entire number. If n1 is not equal to 0, what I'm going to do, I'm going to find the remainder. That means how can I extract all the digit? By just modulo it by 10 and just reduce the number divided by 10. Okay, so remainder the number digits are n1 modulo 10. I need to find whether there is single any odd or not. So let there be a flag which will show if there is an odd or not. Initially the flag is 0. If the r is odd, if r modulo 2 not equals to 0, that means if it's odd, then flag will be 1. This will represent that there is an odd number inside, there is an odd digit inside of the number. Okay. Also, what I need to store, I need to store the maximum digit. I also need to store the maximum digit. Let it be maxi. Initially, its value is 0. Okay. So I will just show the maximum digit here. Maxi should be max of maxi comma r. R represents the digit. Now I reduce the value. N1 should be N1 divided by 10. Now this actually loop will this while loop will loop through the entire number, extract each digit. Then I'm going to check whether the digit is odd or not. If the digit is odd, then I will uh, set my flag. After that, I will keep a track of my maximum digit. Okay. So now what I'm going to check if there is a odd digit in the number or not. So my flag will tell me that if flag is one, that means there is an odd digit. So I can directly return. Sorry, I can return one as my answer. Okay. Now coming to the condition where all the digits are even. So what I'm going to do, I'm going to subtract the condition where all the digits are even. I'm going to subtract my number with the maximum digit in minus equals to maxi. Or for clarity, I'm writing it in this way. N should be n minus maxi. Now what I'm going to check the ones position value. If the ones position value is zero, that means three operation is required. And if the ones position value is anything rather than zero, that means the 10th position value have changed, converted to odd. So I can just rearrange it. So the number of operation we require is 2. So if the ones position value, which I can directly extract by modulo 10, is 0, then what I'm going to do, then just return 3 because 3 operation will be required. Else, just return 2. I think it should work. Let's check. Okay, 3 1 1 0 2. Yeah, it's working fine. Yeah. So this question is also done. So these are so in order to solve this question, you need to understand various what I would say arithmetic things like how can you achieve a even, how can you achieve a odd relation between the numbers and all. So that's all for today. Keep coding. I will again come up with another CodeChef contest. So bye.